Hi, my name is Charlie Peck. I teach computer science at Earlham College, and I'm one of the organizers of the LittleFe project. LittleFe is an inexpensive educational appliance which, in conjunction with the bootable cluster CD Linux distribution, takes the friction out of teaching parallel and distributed computing. The combination of LittleFe and the BCCD include all of the software commonly used for teaching parallel and distributed computing, for example MPI, OpenMP, and the CUDA SDK. Each LittleFe node has a dual-core Atom CPU, 2 GB of RAM, gigabit Ethernet networking, and a CUDA-capable GPGPU chipset. This short video describes the history of our project, who we are, where we are today, and where we hope to go tomorrow. So, sit back, relax, and leave the hard work of provisioning a parallel programming platform to us.
Okay, so basically LittleFe is a small portable cluster with 6 nodes. They designed mainly for the educational purposes. For example, if you're teaching high-performance class somewhere and you don't have access to cluster, right? You have to submit your jobs and everything, programming language programs that your students made somewhere to the cluster that you don't even see at all. And you submit it, and then you're waiting a couple of hours to get the feedback. Usually, we get even emails saying something is wrong with your program, we cannot execute it. And the purpose of LittleFe is to put it inside of the classroom and do the education on move. It's really important for education to know answer right now. Because if we have class today and if we send a program and if we know the result tomorrow, it's really not efficient. If we have that LittleFe inside the classroom, we can do it right now. We can see what is the problem. It's great for educational purposes.
The thing I like most about LittleFe is that people just love it. It's small, it's cute. If you stick it on a table, you're going to get a whole bunch of people clustered around it, pardon the pun, learning about high-performance computing, not on purpose, but just because the LittleFe itself is so fun to look at.
LittleFe was born out of necessity. Our first unit, seen here set up in a hotel room dresser at the SIAM conference in 2004, was a cabling nightmare. In 2005, our students engineered a wooden frame for the boards and networking gear. The baggage handlers at the airport figured out how to unengineer it. Later that year, we learned how to use standard rack mount parts and built our first metal frame, while still retaining the wood mainboard plates for aesthetic reasons. In 2006, we designed the first LittleFe unit that would be mass-produced. We made 15 of those units that year. Some of them are still in use today. In 2011, we designed version 4, our first truly professional system. 25 of these units are in use across the United States now, and we're getting ready to host build-outs that will put 30 more of them in the field this year. We will spend the next year designing and testing gear based on the LittleFe platform that will be used by geology and chemistry faculty and students next summer to measure a variety of water and air parameters and provide computational and communication support at a number of field locations across Iceland. If you'd like to contribute to our travel fund, get in touch. One of our long-term goals is to design gear based on the LittleFe platform that could be used as a cost-effective solution to providing computational support for research groups doing field work in Antarctica.
Let's talk a little bit about what the bootable cluster CD is and what LittleFe is. And it is an interesting collision that you've helped the two of them have.
So the bootable cluster CD is a software platform. It's a live CD that you can put in a computer, boot it up, doesn't touch anything on your computer, so you can do whatever you want, and then reboot and you're back in your regular system. It lets you do all sorts of computational science programs. You can do like n-body simulations, you can do game of life, you can write your own MPI code or OpenMP code. You can, we actually provide an Intel compiler. They're very generous in providing us an Intel compiler that you can download for free off the website.
And Paul Gray pioneered this.
Yes, yeah.
And then you've been an architect of this next version that is Debian-based.
Right. Dr. Paul Gray at the University of Northern Iowa
right.
Designed the first two versions, and at our own college we've designed the third version, which gives us a lot more flexibility in what software and what hardware we can support with BCCD.